y'all are ready, give me a thumbs up. Everybody. Okay, on number 23. It says to find all the values for all points of the graph of the function, which there is a horizontal tangent line. And I want you to write out. If y'all remember Hoy and Bucks, horizontal lines have a slope of 0. And because we're looking at tangent, we are looking for the derivative. The derivative of the x. So let's go ahead and find the derivative. If the power is 3 and I have -4 coefficient, the derivative is negative what? 12x to the what? Squared. So if I have 3x squared, my derivative is 6x. What is the derivative of any constant? 0. So I'm not going to write that piece. So at this point it's saying, hey, my slope is 0. So let's plug in the 0. I have 0 is equal to, and while I'm at it, what happened? Give me an excuse what time it is. Cover your nose, please. We'll talk after. All right. I'm going to factor out a -6. For those of you guys talking, good luck. If you go, I don't know how you got this. So if I let first one equal 0 right here, that's going to give me x equals 0. Second one, if I said equals 0, if you walked in late, you might want to sit down. And even then, I'm upset with you. So 0 and 1/2. And those two are the values where the slope is 0. All right. Okay, if you're ready for 25, give me a thumbs up so I can go over more questions. Okay, 25. Zoomers, you too, thumbs up. Okay, so I'm going to cover this up. Now, I'm going to give you the easiest way possible for number 25. Listen carefully. If you're looking at this going, I'm going to do quotient rule, that's okay, go for it, okay? But I would advise making it, because we have a single term, let's go ahead and make it into one line and no fraction. So let's see how to actually do that. Let's rewrite this. Y is equal to, if I rewrite 6x to the 5th over x squared, doesn't that make the x to be x cubed? Yeah? So I have 6x cubed. For the next one, I see a minus. So we know this squared and that squared completely eliminates the x's, so I have simply -3. Plus 2. Now let's worry about the power. My power right now on my third is bottom heavy by 1 more. But if I'm trying to avoid the fraction, I'm going to bring it to the top with a negative power. So when something is written as a polynomial, it becomes really easy for us to derive it twice. So let's find the first derivative. What is the derivative of 6x cubed? 18x squared. What is the derivative of -3? 0. I'm not going to write that piece. What is the derivative of 2x to the -1? -2x to the -2. It's always one less. Will, you with me? You're zoned into the screen. That means something else. The second one, let's find the second derivative. 18x squared is going to be derived to 36 what? X. And then if I take the next derivative, that's going to give me a positive 4x to the -3rd. And that is all I need. If it makes you happy to bring that x to the 3rd with a positive on the bottom, go for it. But I'm good on this right here. Okay? Yes, ma'am.
So for the very first step, we are subtracting the x squared from
Where?
the very first step.
This one.
Yes.
So 5 minus 2, 3. Okay, let's do the visual one. If I give you anything on the test with a picture, it is a freebie. Okay, so if I make those if I make it worth a lot of points, basically I'm trying to give you free points. Does that make sense? So here I go. So now it's saying from the indicated letter that is pretty much on the points of the axis, is my derivative positive, negative, or 0, or sometimes it could have no derivative. So let's go ahead and look at the following. Do y'all remember what this sharp turn was called? Cusp, thank you. At a cusp, there's no derivative. So none. And I know when I taught it on the notes, I said does not exist. Okay? Because if it doesn't exist, there's none. Okay, on part B. Okay, let's start with actually all the zeros. I see a 0 here, and I see a 0 here. And zeros happen when I'm going from negative to positive, or positive to negative. So I'm going to write my slope is 0. My slope is also 0. So let's find them. C, the slope is 0. At is that E? It almost looks like a C, but that's also a 0. So let's look at the behavior then. And I'm going to go ahead and take out a highlighter. At B, if I were to go ahead and connect my point from A to my C, isn't B within my downward slope? So we know that's going to be a negative slope. And contrary to the other one, it's going to be a what? Positive. Please don't miss this. Okay, I'm done with this page. Everyone go to the next page. Everybody go to the next page, please. Okay, on my next page, oopsie, 27. I don't think I want to worry about 30 or 31, so y'all can just choose to not do it. But anyways, what two numbers on this one? It starts from 27 to 30. There's two 30s, yeah? Yeah, the first 30, yes. We can do the 30.1, okay? You guys good on that? Anybody have a question on the tangent line number 27? Okay, let's go ahead and do 30. Let's see our time. Oh, 10 minutes. We can do this. So it's saying the graph of the derivative of f is shown in the figure. So this is the slope. This right here is the derivative. That's not the original function. So we're going backwards. So I need to figure out which of them is actually the original function. The best thing for you to do is assume it's this, assume that, and so on. Now I'm going to give you a trick. You guys ready? I'm going to give you a trick that could eliminate, especially on your AP test, more than half the choices. Listen carefully. And I'm going to go with the one that's really easy. If your original function is x cubed, when you derive it, I have something x squared. You agree on that, right? One less. If I have x squared, when I drive it, I have something x. So then I want to go ahead and say something. If this is a derivative, and it is a parabola, isn't x squared some form of a parabola? Yeah? So that means my original function was not a parabola. So what I can do at this point is my original function is not x squared, is not x. So here I go. I'm going to say it one more time. My original function, it is not a linear function. That's also a linear. And it is not a parabola. That one doesn't help us at all. Okay? So the following could be one of them. Since I want to go ahead and look at the zeros. Which one should we go for? Should we test C, D, or is that G? E. Okay, which one should we test? And if we get lucky, we do. Give me a letter.
B.
C. Oh my God, B was omitted. Let's start with C. C is 0 here and 0 here. So my 0 is at positive 1 and negative 1. So let's look at our derivative graph. Is my 0 at positive 1, negative 1? No. So where is my derivative at positive 2 and negative 2? Both of these, which is not very helpful, right? The part that's going to help is this. If I make my line where my zeros are, I could then see what is my behavior from the two zeros. That one's going down negative. What is my behavior from these two zeros? It is going up. It is positive. So that means my graph must be below for this one, or my graph must be above for this one. So which one takes the original graph, D or E? E. But this is, right here, is above. So if you can eliminate most of them just by the logic, that will be very smart on your end. Okay, let's go to the very last page. Very last page. Okay, if you're good, give me a thumbs up. I might have a question for maybe one or two, okay? Okay, last page, I mean. Should we just go through all of 33? Okay, we should have enough time for this one. And I'm gonna go ahead and show you guys the card. If you don't wanna take out your card that we made, don't, okay, just for time's sake. So I'm gonna go ahead and put on here. Position is the original function. Velocity is a derivative. Acceleration we will do later. Okay, so I'm gonna go ahead and put this up. All right, number 33. Let's see. I want someone to read. Tyler, let's read number 33. Story time, everybody. Go.
Suppose that a baseball is tossed straight upward and that its height in feet as a function of time in seconds is given by the formula h of t equals 128t minus 16t squared.
So then, let's go to underline the two things. We have instantaneous velocity and we have average velocity. Average velocity is average rate of change, which is basically the slope, y2 minus y1 over x2 minus x1. That one's easy. The instantaneous velocity that I'm going to also put the card back up on was our limit feature. And I told you guys after I taught you guys this, I gave you a trick on derivatives, right? So let's find the derivative. So on this one, it's going to be our derivative of the h prime of t. The velocity is the first derivative. So I'm going to go ahead and write velocity, v of t. I could have written h prime of t, but I don't feel like it. What is the derivative of 128t? Boom. What is the derivative of negative 16t squared? Negative 32t. Boom, done. That was the first part. Now second one is saying, okay, we're okay with that. Let's take the original this time and find the average velocity. So we're doing between these two intervals. So if you want to be specific, write with me. H of 4 minus H of 1 all over 4 minus 1. And the next piece is going to be tedious because I'm going to write everything out. 128, now plug in the 4s, minus, now watch the next piece, because when you guys are using the calculator on this, you'll mess up because you forget double parentheses, which I call it a bracket. Because when I subtracted the whole thing, I think of distribution. So now I'm going to plug in the 1. 128 times 1 minus 16 times 1 squared. Now I'm going to close that bracket. All over 4 minus 1 is 3, so I'm going to be okay with that. I think it's time to clean, right? Okay, I'm going to have y'all plug this on your own later. So I'm going to go ahead and say something feet squared, feet second. And I think it might be a good place to stop.